Hi students, now we are going to discuss gamma decay process. You have already studied what is a gamma ray. Gamma ray is a part of the electromagnetic spectrum. So gamma ray photon does not have a charge number as well as a mass number. Hence when a nucleus is emitting a gamma ray photon, only energy will be lost by the nucleus. And there is no change in the charge number and the mass number. Already we have studied during radioactivity simultaneously alpha, beta and gamma does not exist. So a parent nucleus may either emit an alpha particle and then followed by a gamma ray photon emission, or it may emit a beta particle and then it may follow up by a gamma ray emission. So mostly when a parent nucleus emits either alpha or beta, the newly formed daughter nucleus will be in the excited state and it will try to return to the ground state, during which gamma ray photons are emitted. So gamma decay process is always a follow-up process after a beta decay or alpha decay, mostly beta decay process. Okay students, now during a gamma decay, so the gamma ray photon is denoted by the symbol like this, gamma symbol, and it has no charge, also it has no mass. Now with the two examples I am going to explain the gamma decay process. So the example number 1, I will take cobalt. So the cobalt nucleus is having a charge number 27 and mass number 60. It is emitting a beta particle. So this cobalt nucleus is emitting a beta particle, that is beta minus, an electron, and it becomes a nickel. So this becomes a nickel. So during this beta minus decay, the charge number increases by 1. So nickel is having a charge number 28. Mass number does not change. So nickel is having a mass number 60. But I will put a asterisk mark. This star symbol indicates that it is in the excited state. So nickel is now in the excited state. This is the beta decay process only. Beta minus decay of what? Cobalt. During which nickel 2860 is formed. This is the daughter nucleus. Since the daughter nucleus is in the excited state, to come down to the ground state, it may emit either a single photon or 2 or 3 photons. These are called as gamma ray photons, and hence this decay is called as gamma decay. Okay students, now let us see that what type of photon it is emitting. So this is the excited state. From here it is coming to the ground state in 2 steps. In 2 steps it is coming down to the ground state like this. So in the first step it is emitting a gamma ray photon, gamma 1, and it is equal to 1.17 million electron volt of energy. And in the second transition, another photon it is emitting, that is equal to 1.33 million electron volt of energy. So after emitting these 2 gamma ray photons, this nickel which was in the excited state has come to the ground state. So nickel 2860 has returned to the ground state. This type of decay process only is called as the gamma decay, and the summary of gamma decay is, during a gamma decay there is no change in the charge number, there is no change in the mass number, but the daughter nucleus will lose some energy in the form of gamma ray photon. Now another example I am going to take. So this is example 2, during which I will take a boron nucleus. Boron is having a charge number 5 and this isotope is having a mass number 12. Boron 512. So it is also emitting an electron. So this is a beta minus decay. So during this beta minus decay, what change does the nucleus undergo? We have already studied. Charge number increases by 1 means 5 becomes 6. So what is the element having atomic number 6 is carbon. So this carbon is being formed, charge number is 6 and mass number does not change, and this star mark indicates that it is in the excited state. So now this carbon is in the excited state. So to return to this ground state, only a single transition is undergone by this nucleus. So there is only a single transition down, and it is emitting 4.4 million electron volt. 4.4 million electron volt. So after emitting this, now carbon 612 is coming to the ground state. That is a stable nucleus is being formed. So this is another example for the gamma decay process, and it is found that during this beta decay 9 million electron volt of energy is emitted during this beta minus decay process. Then after that a follow-up of gamma ray photon is having an energy of how much? 4.4 million electron volt. So the net transition, the net energy released is this 9 plus 4.4 is 13.4 million electron volt. So this type of transition by emitting a gamma ray photon only is called as a gamma decay process. Hope you should have understood. Fine.